All right. So, good morning, good afternoon, good evening, wherever you are. Welcome to this first session on the AskTOM Office Hours on GDS. What we'll talk about today is we'll introduce you to Global Data Services. It's a feature of Oracle database that's been released as part of 12.1 a few years ago. And then my name is Nagesh Battula. I'm the product manager for Oracle Global Data Services. Right. What we'll talk about today is the workload management challenges of when you're dealing with replicas. We'll introduce how GDS addresses those challenges. We'll talk about the concepts and architecture of GDS, and also we'll take a look at various use cases on how GDS could be employed with Active Data Guard as well as GoldenGate. Okay. So if you look at the challenges of replicas, let's say in this example, I'm showing two databases. One is a primary, one is standby. They could be in the same data center or they could be in different data centers. When you're running your read-only workloads, right, there isn't a mechanism. If you're running it against a standby, and if that standby goes down, there's no mechanism for automatically failing over that service to another database, for that matter, primary or another standby, right? In the current, in prior to 12.1. And also there is no mechanism to load balance your workload across the databases. Let's say in this Active Data Guard example, I have read-only workload that I'm running. I don't have a mechanism without GDS to effectively load balance this workload across these two replicas, right? So what we did is we've introduced a feature called Global Data Services. It's basically a vehicle for you to manage your client workloads automatically and seamlessly across replicas, right? If I step back and see, you've been using the concept of service with Oracle RAC databases, right? With which you can load balance the workload across instances of a cluster, or you can do failover of the service from one instance to the other, right? What we did is we've extended that notion of service to replicated environments. That means we created a new concept called global service, with which you can load balance your workload across databases, or you can do service failover across databases, etc. Right? And we'll talk about all the details of how the global services work later on. But from capability standpoint of view, what GDS offers is it gives you workload routing based on the load, locality, and the replication lag, right? And also it allows you to do service failover across replicas. So the benefits, you get to maximize your application performance with the load balancing capability across databases. And also you'll be able to mitigate the downtime, whether it's planned or unplanned. You can mitigate the downtime big time with GDS. And you can manage your workload across these replicas with simple interface, right? With one interface, both command line or with Enterprise Manager, right? So here it is with GDS, you get uniform and well-balanced workload across these replicas. And if a database crashes, we automatically fail over the service to another database, and we allow you to connect and continue the workload there. Okay. So bottom line, with GDS, you get centralized service management. With one interface, as I said before, you can manage your workload across replicas. You could do workload routing based on the region, the locality, and also the replication lag. And you can do load balancing, both connect time as well as runtime. And then you can do service failover. And with Active Data Guard, you can even assign, you can even do role-based global services. Okay. So now let's look at the architecture diagram of GDS, right? So if you look at the bottom, you have your application databases. In this example, I'm using sales application database, which is, there is one primary and a standby, and it could be using Active Data Guard or GoldenGate. At the application tier, you have the connection pool based clients running. And then in the middle, between the app tier and the database tier, you have what's called as GDS, the Global Data Services, and it has two components. One is the Global Service Manager, and the other one is the catalog, right? So now, Global Service Manager, think of that as a global smart listener which will allow you to um, load balance your workload across databases, both at the connect time and runtime. And they monitor the databases. And if the database crashes, it'll also do the service failover using the global service mechanism. Right? And all your connections will go through these GSMs. These are the listeners, and these listeners will redirect you to the right database based on the policies that you get to set. Right? These are not database instances. These are simple Oracle listeners, but they have been beefed up in support of replicated environments. Okay. So that's Global Service Manager in a nutshell. And there is another component called catalog, the GDS catalog. This hosts the metadata of your GDS infrastructure. What are my replicated environments? What are the global services? What are the regions? Right? All that information, the basic information is persisted in the catalog. It's a very small scale database. You don't need a separate database for it. You can also co-host it along with your RMAN catalog or Enterprise Manager repository, etc. Okay. Sorry. Now, we recommend that it needs to be protected with a standby. And we also recommend that you need to have a pool of GSMs on both data centers, right, for high availability. I'm showing 3 GSMs in this example. The bare minimum number of GSMs is 1. For high availability, you want at least 2. And if you want to have multiple pools of databases that need to be supported with a single GDS infrastructure, we also recommend that you have at least 3 GSMs in each data center. Okay. So as I said, you could have pool of 20 such database pools that you could add to the GDS infrastructure, and then they all can be managed by these set of GSMs in the catalog. Okay. Now, here are the details about what a GDS infrastructure can support. 20 pools, as I said. You can have 10 regions, 5 GSMs in each region, 300 database instances, 1,000 global services, and thousands of mid-tier connection pools. The databases in the GDS governance should be using Enterprise Edition 12.1 or greater. They could be single instance or rack. They could be CDBs or non-CDBs. They could run on Exadators, right? As I said before, you can manage all of this with interface called GDS-CTL command line interface, as well as the Enterprise Manager plugin. The licensing standpoint of view, if you're using Active Data Guard or GoldenGate, a GDS is included in it. There is no additional purchase from that perspective. Okay. Now, how do I deploy GDS? It's quite simple, right? At a high level, like how you have database media and client media till now, starting with 12.1, you also have GSM media, the Global Service Manager media, that you download and install on various small-scale VMs where you run this Global Service Managers. And you download and install it, and then you pre-create a catalog database, right? And then there are some basic GDS administrator accounts and privileges commands that you would run, and I'll show you what those are. After that, you would do the configuration of GDS. These are one-line commands for creation of the catalog, for the creation of GSMs, the regions, the GDS pools, the databases, how you're going to add it to the pool, and how you're going to create the global service for your replicated environments. And then finally, you would set up the client connectivity. You would adjust the TNS names to use GSM listeners instead of your regular database listeners or scan listeners. Okay. Now let's look at those steps, right? I mentioned you download and install GSM, and then you pre-create a catalog database. Once those two things are done, on the catalog database, when you create a 12.1 or greater database, there is a default user called GSM cat user. That needs to be unlocked, and you will have to set the password accordingly. You should also create a super user. In this example, I'm saying my GDS admin, and then the GSM admin role needs to be given to that particular super user, okay, administrator user. And for each database that you would add to the pool, there is also a default GSM user that needs to be unlocked, and the password needs to be set. Right? These are the prereqs. Now let's go into the configuration of GDS. What do I have to do to set up GDS for your given application. First thing, I'm not going to go into the details of the syntax, but allow you to understand, at a high level, what commands would you use, and that makes up this configuration. Okay, so the first thing is create catalog. As I mentioned, you already pre-created a catalog database, so you're going to create a GDS catalog in that database. You would specify which database that you want to create the catalog on, what are the regions, what's the super user and the password, and then once the catalog is created, you would do add GSM. As like I said, GSM is a regular Oracle listener, so it would have a listener port that you would have to assign, and then you would tie up the catalog that it is to be connected to, and then region that it's mapped to. And this command you could run any number of times for however many GSMs you may have, right? And then once you add the GSMs, you can start them, right, with the start GSM command. After that, you create a pool. In this example, I'm creating sales pool. Okay. So then after that, you would add databases to the pool, right? If I have two databases, DB1 and DB2, I would add those databases to the pool. But if you are in an active data guard configuration, broker configuration, you don't need to use add database. You can say add broker config. So if you have like multiples of databases in the broker config, one primary and multiple standbys, all those databases could be plugged into a GDS pool with that one command. Okay, with that command called add broker config. Once the databases are added, you would say add service. In this example, I'm creating a sales query service. My preference is that it needs to run on DB01. But if the DB01 fails, I would want to fail over that service to DB02 automatically. Right? So that's how I'm creating my global service. And once I define it, I would start the service on that pool. Right? So that's all I would do. So on the back end, I would create the catalog, create GSM, create the pool, add database to the pool, create my global service, and start it. Right? That's at the back end. And then from the client side, I would adjust my TNS entry. The TNS names configuration is very similar to what you've been using before in the case of rack or even for that matter, non-rack. In this example, I'm showing two address lists and set of listeners. These are nothing but the GSM listeners that have been created using add GSM command in the previous slide. So I would list out all the GSMs in one address list. In this example, it's in data center A. And my other address list will have the GSMs that belong to the data center B, right? And the other important thing that needs to be noted here is the service name is a global service that you just created, okay? And the region you're coming from. This is optional, and this is needed only when you want to do region-based routing. You're telling GDS which region you're coming from with this particular clause, okay? So bottom line, the TNS names is exactly what you've been used to. It's except for the listener endpoints, you would use GSM listeners instead of database listeners or instead of your rack scan listeners. Okay? That's from your client side. Now, like I said, GDS will allow you to do service failover, load balancing across replicated databases, locality-based routing, and all the good stuff, right? Now, it won't stop there. It also publishes fan notification anytime it does service failovers, or for that matter, even to provide runtime load balancing advisory, it provides fan notifications. And the best of GDS is subscribing to the fan notifications by the clients. Then you get the intelligence from GDS. Anytime you have this changes happening in the backend, the clients get notified if the service has failed over, or if at the real time you get the runtime load balancing metrics, so you can route your workload accordingly, right? And now, what do I do to make my applications GDS ready? First, of course, you define a global service. We talked about that. We recommend that you would use the Oracle integrated connection pools, whether it's OCI, JDBC, ODP.NET, WebLogic, etc. If you're using Apache Tomcat, JBoss, IBM WebSphere, we do support that, except for in those scenarios, you would use Oracle UCP, the Universal Connection Pool, as your data source. From the connection perspective, both in TNS names and your URL, you would use GSM listener endpoints, and you would use all the max availability best practices, basically the connect timeout, the retry count, delays, and transport connect timeout, etc. These are the best practices that have always been there. We retain that even with GDS. And then you should be using global service name. And then for locality-based routing, you would use region. Okay. We recommend that you would go with the 12.2 clients for one reason, which is the fast connection failover is automatically enabled. That means your connection pools are automatically subscribing to the fan notification with this call that's made in the UCP. Okay. And then if you want to do graceful failovers, you could also have a draining period set, right? In this example, the planned draining period is for UCP. I'm saying 30 seconds. In 30 seconds, I would have to gracefully drain my connections and move over to another database where the service has failed over. Okay. So those are the prereqs for the application to get the best out of GDS. Right? Now, let's look at the use cases. I'm going to talk about use cases on how GDS can be employed with Active Data Guard as well as GoldenGate. Okay. Now, in this example, I'm talking about service failover for Oracle GoldenGate master and replica scenario. Okay. So I have GoldenGate configuration. I have my master database, which is DB01, and my replica, which is DB02. And I want my ordering service to be running on DB01. If this fails, then I want the service to be failover to DB02. To get that behavior, the service failover behavior for GoldenGate configurations, I would define my global service like this. I'll say add service, define my service name. Here is my pool. My preferred is DB01, available is DB02. Right? So with simple setting of the attributes preferred and available, you get the behavior of service failover from one to the other if that database crashes. This is for the service failover in the case of GoldenGate master and replica. Now, there's another use case called load balancing for reader farms. Many customers do this, whether it's Active Data Guard or GoldenGate. So they want all the read-write workload to be sent to the primary, and the read-only workload to be balanced across all the standbys. In this example, the reporting service needs to be balanced across the standbys. Okay. To get that, you need to create two services. One, of course, for the read-write workload, and the second one is for the read-only workload. So for the read-only workload, in this example, I'm showing reporting service. I'm telling the system it can run on any database as long as the role is physical standby. That means it's going to run on these databases, right? On the physical standby databases. And I'm also defining two goals: the connection load balancing goal, CLB goal, long for long lived connections. Typically, your connection pools use this. And then RLB goal, you have two options there. You could use as a service time or throughput. Right? In this example, I'm using service time for RLB and then long for connection load balancing. Right? Just by setting these attributes, I'm making sure that all my incoming connections that are using reporting service are well balanced across these standbys. Okay? So that's the power of GDS. You don't have to write any custom code to load balance. You just set your attributes for the global service and use this global service for the workloads that are running the reporting. Okay. So now we looked at service failover, we looked at the load balancing for reader farm. Now let's look at load balancing for active-active GoldenGate. Right? GoldenGate can also do multi-master configuration. Right? In this scenario, I have two databases. The assumption is the application handles a multi-master conflict resolution. Right? And then in this case, I could run read-write workload as well as read-only workload on any database. So if my goal is to load balance my workload across these two master-master databases, I would define my service, my order entry service in this case, to have preferred all. That means run on any database, but my connection load balancing goal is long. Okay. So with these attributes set, all my incoming connections are load balanced across both these databases. So this includes both read-only as well as read-write workloads. Okay. So now that's load balancing for active-active. Now, how about region affinity? So many times customers want to route their client workloads to the nearest database in the nearest data center. Right? In this example, for example, data center 1 clients closer to the data center 1 should be routed to a database in data center 1. Likewise, clients closer to data center 2 should be routed to a database in data center 2. Right? So how do I do that with GDS? So in this example, I'm using GoldenGate in a multi-master conflict. Now, multi-master conflict resolutions. And then now when I create my create my global service, I would say preferred all. That means it can go to any database, but the preference is locality local only. That means these clients should be taken routed to the nearest data center, right? But if there is no database in that data center, my second option is to have a region failover. That means as a second option, I can go to another database in another data center, right? So bottom line is preference is to a local database. And if that database doesn't exist in the data center, or if it's down for whatever reason, then my second option is go to a remote database, right? That's region-based routing with GDS for GoldenGate. Now, service failover for active data guard, right? In this example, I have replicated configuration using active data guard. I have my order entry service running on the primary database, my reporting service running on the standby. My goal is if my standby goes down, I want my reporting service to fail over back to the primary. Okay. To do that, I define my global service like this. I'll say preferred all, reporting service can run on any database, but my first preference is to run this on the database that's running as a physical standby, right? And if the last known physical is down, I can even fail over to the primary. That means I can run the service back on the primary as well, right? So you're giving the priority that all the read-only workloads should run on the standby, but if that standby goes down, now fail over that service to the primary. In that scenario, you would run both the order entry service and the reporting service on that primary. Okay. So another interesting one is a role-based global service for active data guard. I take the same example. I have an active data guard configuration, order entry service running on the primary, reporting service running on the standby. Okay. Now, so maybe as a DB, I want to do a switchover, for example. So I run the switchover command using the broker. The moment the switchover finishes, the data guard switchover finishes, GDS recognizes that and relocates the global service accordingly based on the role that you have defined for that service. So to get that, you would define two services. One is the order entry service that needs to be run on the primary, right? And the reporting service, whose preference is to run on the database role physical standby, right? Anytime there are any role changes, whether it's due to switchovers or failovers, GDS will relocate those global services based on the role that you have defined for those services, like this, right? So you get that with GDS. This is an interesting one, routing based on replication lag tolerance. So in this scenario, I have a database and a local standby in one data center, and also have a remote standby in another data center. Many times when you have a remote standby because of network issues, etc., this particular database may lag, which is in the remote data center, right? And if you're running your reporting, business reporting workload on that particular standby, they may be seeing data that's not current, that's lagging behind, and maybe you may not want to do that. In that case, you can set replication lag tolerance, right? What's your threshold for that? The threshold is defined in seconds. Let's say 180 seconds. If the replication, if this particular standby DB03 is lagging behind by 180 seconds, then I want the workload to be routed to another database which is not lagging behind, right? To get that behavior, I would define my global service, in this example, reporting service, whose role is physical standby, and the replication lag tolerance is 180 seconds. Right? If the lag exceeds that limit, we shut the service down on that particular database, and then we route the next set of incoming connections to another standby. So the beauty of this is for your application workload, they get better data quality because now you're not accessing the data from a database that's lagging behind. Okay. So those are the use cases for both Data Guard as well as GoldenGate. There are a couple of interesting things I want to bring out. How do you mitigate unplanned outage with JDS? And also, how do you do planned outage, right? So in this example, I'm going to talk about unplanned outages, right? So what's the best way to mitigate? There are certain prereqs that I have to do. From the applications perspective, I want to use the Oracle Integrated Connection Pools. We talked about that. UCP, ODP.NET, OCI, etc. Right? And of course, we do support third-party application servers, IBM WebSphere, Apache Tomcat, JBoss, etc. From the application configuration side, we need to subscribe to the fan notification using the FCF. As I mentioned, if you're using 12.2 clients, you're good there. And then we also recommend to follow all the MA best practices on the TNS connectivity, retry count, connect timeout, and transport connect timeout. Right? So those are the prereqs. Now, what are the unplanned events? In the case of GoldenGate and Active Data Guard, it's a global service failover. That means if a database crashes, GDS automatically fails over the global service, right, to another database. And then the other one is for Active Data Guard, it's the Data Guard role transition, whether it's failover or switchover. So in those scenarios, the moment these failures happen, GDS relocates the global services and it publishes a fan notification that this particular service events have occurred, that the service is down on one database, the service is up on another database. Those fan notifications, the fast application notifications, are sent by GSMs to the connection pool clients. Right? The moment the fan notifications are received by the connection pool clients, the sessions start draining. That means the new work requests are automatically redirected by GSM listeners immediately, okay, to the new database where the service is coming up. And the idle sessions are released immediately as well. So, but the checked out connections, they would receive invalid connection, right? The application would then, what it would do is it will close the connection and gets a new connection from the pool. But when it gets a new connection from the pool, now it will automatically get this connection on the new database where the service has come up, right? This is done completely automatically by the connection pool. What GDS offers is that fan notification when these services have been relocated, right? So bottom line is, when these unplanned events occur, GDS will allow you to mitigate the downtime from the application perspective. You would gracefully move over from one database to another, right? That's the unplanned outage. What about my planned outage, right? So let's look at that. The same requirements from the application side and the application configuration side. I'm going to go over that again. Now, in this example, I have GoldenGate configuration, right? In the master replica type of a scenario. All my workload is running on the master. And my goal is I want to apply a patch. Let's say it's a database patch or infrastructure patch or for the matter, schema upgrade that I want to do, right? I'm going to go do my schema upgrade on OGG2, the second database. Once the schema is upgraded or the patch is done, all I would do is, as a DBA, I would just run one command from GDS-ETL called relocate service. I'm going to relocate this global service from OGG1, the first database, to OGG2, the second database, right? I execute one command and then sessions start draining, just like how we observed last time. So GDS publishes fan notification, right, that it is a planned event. The reason code is user. And then what happens is the new work is automatically redirected by the GSM listeners to the OGG2. Idle sessions are released from OGG1 automatically. And those active sessions are released when they finish and they will come back when those connections are checked in, right? That's when they're released. And then that's how you gracefully move over your workload from OGG1 to OGG2, right? And that's an interesting capability. It's not just the service failovers, it's the intelligence that JDS publishes to the connection pools with which you can mitigate your downtime big time from the application perspective. Okay. So bottom line, GDS, we talked about that it provides workload routing, load balancing, both connect time as well as runtime. And we also talked about how it fails over service based on the policies that you get to set. And it's a vehicle for you to manage your workload across replicated environments seamlessly and transparently. Right? The key benefits, GDS allows you to maximize your performance of your application as well as the availability of it. We talked about that. Performance via the connection load balancing, availability via the fan notifications, when the service failovers happen, right? And we talked about how we mitigate the planned and unplanned outages. And the best part is better resource utilization. You don't have underutilized resources on one side and overutilized on the other, right? You're effectively managing your resources for your given application. Okay. I want to call out a few things. We do have quite a bit of collateral that's been captured in the GDS OTN page. I would strongly encourage you to try out, go to the oracle.com, go to GDS on OTN and try out the white papers, their webcasts, the customer collateral. There quite a few cookbooks as well on how to deploy GDS, how to exercise my use cases for Active Data Guard as well as GoldenGate, right? And I do also blog on GDS, so do take a look at this particular link as well. Take a look at all the posts that I've done so far that talk about the details of the use cases that we covered, and also the in-depth architecture and then concepts of GDS as well. Okay.